Hello everyone and welcome to my steps. Today we are going to solve problems involving the area of 2D shapes. I have chosen in the beginning two questions that have been in the past GCSE paper. And this particular question is one of those questions that is on both papers foundation, as you see, it's foundation 2016 and GCSE higher tier, higher 2016. So let's have a look at the question. So it's about determining the area of rectilinear shapes. Now, don't be put off by a big name. Sometimes if you have big names in a question, don't get put off. Just look what the question wants, or read the rest of the question carefully and just do what the question wants, okay? Right, so we have a rectilinear shape, which is basically is a shape with closed, it's a 2D shape, closed straight lines, with straight lines, closed, obviously with straight lines and 90-degree angles. That is a rectilinear shape. Okay, it says Angie is going to varnish the floor. So this is the shape, as you see. She needs 1 liter of varnish for 5 square meters of floor. There are 2.5 liters of varnish in each tin of varnish. Angie has 3 tins of varnish. 3 tins of varnish, 2.5 liters in each tin. And then she needs 1 liter for 5. So they need 1 liter for 5 square meters of floor. How many tins will she actually need? So what the problem wants us, so we need to find out how many, not just how many liters, but how many tins of varnish. So which means you need to be able to find out the area of the whole shape. Now, as you see, the rectilinear shapes, we can divide them. We can see them as compound shapes. So we can divide them in more simple shapes. So we can divide this shape into 3 rectangles. It could be 3 rectangles. It could be 2 rectangles in a square. So let's see. So it depends of the length of the side. So let's have a look. So, okay, now let's find out the sides. Let's label all the sides of each 3, each of the 3 shapes that I have created. So this side is 6, so this side here is going to be 6, of course, because they're parallel and equal. And if this is 2.5 meters, then this one here is going to be 2.5 meter, parallel sides in a rectangle. So we created this. This is a rectangle because we created this one ourselves, okay, by drawing this particular dotted line, perpendicular dotted line. Okay, same for this one here. This angle here is going to be 90 degrees. Obviously, this angle is 90 degrees. And so this side is going to be 2.5 meters. Okay, and let's have a look at this other side. Obviously, 6 take away 2. This one is going to be 4 meters. So 4 meters on this side and 4 meters on this side. And now let's have a look at the opposite side, these 2 sides, the other pair of parallel sides in this rectangle. I'm going to call them rectangle A, just to make it more visual, more clear and neat. Okay, rectangle B and rectangle C. So all these sides from here to here was 10 meters, as you see. But we know this part from here to here is 2.5, 2.5, so 10. Take away, I'm going to write it up here. 10, take away 2.5 times 2. And the answer is going to be 10 take away 5, so 5 meters. 5 meters. So this side here is going to be 5 meters. And this here is going to be 5 meters. See, so we divided the whole 10 into 2.5, 5, and 2.5. So it's not 10. This 10 does not belong to this part of the rectangle. Okay, now what we need to do now is to find the area. Now we know, as you see, all the sides, all the lengths of the sides. Now let's find the area. Now, this rectangle A and C, both rectangles are the same. So area of rectangle A, I'm going to call it like that, is the same as area of rectangle C. Okay, let's find out. So it's 2.5 times 6 for both of them. 2.5 times 6 equals 15 square meters, remember? And the area of a rectangle, I'm going to call it area of rectangle B, I'm going to put AB, is going to be 5 times 4. So this bit here, so this side is 4. So 5 times 4 equals 20 square meters times 4. 20 square meters, okay? Now, we need the total area. We need the total area of the whole rectilinear shape. Obviously, it's made of a total area. Total area is made of area of A plus area of rectangle B plus area of rectangle C. Now we know rectangle A and rectangle C is the same, it's 15, so it's going to be 15 times 2, 30. I'm going to write 30 straight away, 30, it should be meter. 30 plus 20 equals 50 square meters. So this is the total area. We know the total area. Now let's get back to the problem. It says Angie needs 1 liter for 5 square meters. So 1 liter for 5 square meters. Okay. How about for 50 square meters? Can you see? So she needs 10 times more. She's going to need, as the surface area is 10 times bigger, okay, 5 to 50 is multiplied by 10, right? It's a proportional. The area with the amount of varnish she needs is proportional, as you see. So 1 liter times more. So she's going to need 10 liters. 10 liters of varnish. But the question doesn't end here. It doesn't say how many liters. It says how many tins she will actually need. Now, we know she needs 10 liters. And we also know that there are 2.5 liters in each tin. So how do you do this one? So we're going to divide to be able to find how many liters. So how many tins does she need? So 10 divided by 2.5. The answer is going to be 10 liters divided by 2.5 liters, because there's 2.5 liters in 1 tin. So the answer is going to be 4 tins. All right. This is the final answer, 4 tins. So what we did first, let's say step 1, we found out the surface area, the total surface area. Step 2, we found out how many liters of varnish Angie needs. And step 3, we found out how many tins of varnish does she actually need. Let's have a look at the next question. Question number 2. Again, this is another question. It is pretty similar to the first one, another question that you will find in both foundation, as you see, foundation and higher tier. The diagram shows the plan of a floor. This is the plan of a floor. Again, we're dealing with another rectilinear shape, a shape with straight lines and right angles. The area of the floor is 138 square meters. Work out the value of x. So we need this x here. And we need the area. So we need the total area of the whole floor. Again, being a rectilinear shape, we can divide. I mean, we can do this here, divide it here or divide it there. I'm going to go for this line this time. Okay, I can divide the shape into two rectangles. And this way, I can write down the area of each of these rectangles. I'm going to call it again. You feel free to always label shapes, because it always helps to solve the problems if you deal with problems, if you deal with diagrams and shapes. So shape A and shape B, a rectangle A and a rectangle B. So how do you find the area of rectangle A? I'm going to write it here. Angle A. So it is going to be, now it's clear. I have the length and I have the width, so 15 times 8. 15 times 8 equals 120, and this is meters or square meters. Okay, the area of shape A. Area of shape B. Now, before we do the area of shape B, we need to calculate the length, okay? We have the width, is 3 meters. How about the length? This, I'm gonna call it an L. How do I find this out? Now, as you see, the whole side from here to here, from this point to this point, it is 15 meters. All of this is 15 meters as parallel sides in a rectangle. So 15 meters, 15 meters. And because all of this is 50 meters, this bit is x. So the length for a rectangle B is going to be, so length of a rectangle B, let's say of B, a rectangle of B, okay, shape B, is going to be 15 take away x, 15 take away x. So the area of shape B or rectangle B is going to be how much? Now we have the width 3 that multiplies 15 take away x, just like that. Right, so what do you have in a problem? We have the total area of the whole floor, so A plus B. We have now the area of A is 120 square meters. We have the area of B is 3 multiplies 15 take away x. Okay, I'm going to put, if you want me, square meters again, of course. And so both of them, I'm going to add both of them. Both of them will make 120 plus 3 open the bracket 15 take away x equals. So this is the total. So total here, total on the other side is 138. And this is given by the problem, 138. See, total equals total. It makes sense. Okay, now here we have an equation to solve. Let's do this one. So we're going to expand the bracket first. So this one becomes 120 plus 45, because it's 3 times 15 and 3 times minus x, minus 3x. Minus 3x equals 138. Okay, what I'm going to do now, I'm going to straight away get rid of 138. I have more numbers on the left-hand side, and I have this negative sign here. So I'm going to get rid of the negative sign by taking away minus 3x from the sides, by doing plus 3x plus 3x. And I'm going to get rid of 138, so I get 3x here. So I can take away 138 straight away from the right-hand side and from the left-hand side too. All right, so this is how I get rid of the x's and 38s on this side. So what do I have now? On the left-hand side, I have 120 plus 45 minus 138, okay, equals 3x, all right? Now, 120 plus 145 is 165, so I will continue my solution over here. So it's going to be 165 minus 138 equals 3x. 165 take away 138 is going to be 27. 27 equals 3x, right? And how do I get rid of the, we need to get rid of the 3, because I just need the value of x, so divided by 3 both sides, okay? Divided by 3, divided by 3, so x equals 9. X equals 9, and we found the value of x. That's it. We don't need to go any further, because the question doesn't ask us to do anything else, just find the value of x. So anytime you find a solution, you solve, let's say, a part of a problem, or just a question, go back to the problem and read it and make sure this is what the problem wants, because sometimes the value of x is not the end of the problem. It could say, now do this, or now do find something else. Okay, so x equals 9. It is the right answer to this question. Okay, stay with me. I'm going to solve more similar questions. So problems involving different shape, different areas of the shape in my next video. So for now, thank you very much for watching my steps. And thank you for supporting my steps. Bye-bye. Have a lovely day.